First, we shall look at roundness. Roundness is sometimes referred to as circularity. What we shall first do is take an out of round part, and then we'll find the center of rotation, or the axes of rotation. This is sometimes quite difficult to find, since we have to find the least squares best fits a circle. Then from that least square best fits circle, calculate out the center of rotation. We then rotate about this center of rotation, and with the dial indicator, we'll measure the roundness. As we rotate the part, the total indicator reading is our roundness value. And providing that our total indicator reading does not go outside of our tolerance zone of 0.005, then the part can be considered as in tolerance. If it goes outside of this tolerance zone, then the part is out of round. Now let's take a look at how we'd inspect roundness in our readout. Our readout is not the ideal solution for measuring roundness, but by taking as many points as possible, it can give us a reasonable good idea of our roundness value of a circle measured. To do this, we need to take as many points as possible. So I'll click on my cross lines, I'll go to Tool Options, and I'll change my maximum circle points to 99, then push Finish. Then I'll click on my cross lines once more, and I'll select Multi-Edge. Then I'll select Circle. Now since my middle circle here takes up less than 75% of the field of view, I can just simply push the Enter button to take my points. Now I can go to the View tab and view my roundness. This is my out of round in my view window. F, which stands for form, is the out of round value. Now what I can do is I can go to Tolerance, and I can click on the roundness tolerance and enter in a value. I shall enter in 1 millimeter. And push Finish. The little green square next to my circle shows that this has passed tolerance. This is how to inspect roundness in the readout. Now let's take a look at concentricity. Concentricity is sometimes referred to as coaxiality. The technical description of concentricity is the condition in which the axes of a cross-sectional feature elements of a surface of revolution are common to the axes of a datum feature. Let's take a look at this in more simplistic terms. We'll take our feature to be measured, and we'll measure our feature to datum A. We'll rotate the part about datum A's axis point. As we rotate the part around datum A's axis point, the center point of a feature that we're measuring rotates around that axis point, creating a diameter. It is this diameter which is known as the concentricity diameter, and providing that this diameter is no greater than the tolerance specification of 0.05, then we're within tolerance. If it's outside of this diameter size, then we're out of tolerance. Now let's have a look at measuring concentricity in our readout. We measured the inside diameter in our previous illustration, roundness. So instead of measuring this again, we'll use the inside diameter in this illustration for our datum A. And we'll measure the outside diameter and compare the concentricity of the outside diameter to the inside diameter datum A. Again, I shall take 99 points around our outside diameter. To do this, I'm going to use the multi-edge probe once again, and I'll press on Circle. Because our outside diameter takes up more than 75% of our field of view, I have to first measure 3 points around the outside diameter by moving the stage. I shall take 1 point here, 1 point at the bottom, and 1 point here. Then I shall position my green arrow inside the red circle, stop moving the stage. Then I shall reposition the green, move the stage in the direction of the green arrow until my green arrow is inside the red circle. And there are my 99 points. Now what I shall do is select my circle 2, I'll go to tolerance, and I shall select concentricity. And for my tolerance zone, I shall enter in 0.3 millimeters for this illustration and push finish. You see that in this case, our concentricity has failed. It has come out at 0.621 millimeters, and our tolerance zone is 3 millimeters. This is what's known as a failed condition. This is how you measure concentricity in the readout. There are two types of ring-out specification, circular ring-out and total ring-out. Total ring-out can be viewed as a three-dimensional ring-out and involves moving a dial indicator up and down a three-dimensional part, such as a cylinder, while it is being rotated around its datum axis. Since video and optical systems are not capable of measuring in 3 dimensions, total ring-out is not available on any of our readout systems. Circular ring-out is a combination of roundness and concentricity. We shall take our part and we shall rotate our part about the datum A's axes as we have done before. And while we're rotating the part, we'll record the total indicator reading, which will be our circularity ring-out. As our part rotates about our datum A axis, you'll notice our concentricity diameter from our previous illustration. Circular ring-out can be viewed as a combination of concentricity and roundness. Our total indicator reading is our measured circular ring-out value. Providing that this reading does not go outside of our tolerance zone of 0.1 millimeters to datum A, the circular ring-out is within tolerance. Outside of this zone, our circular ring-out will be considered out of tolerance. Now let's have a look at measuring circular ring-out in our readout. In our previous illustrations, we had already measured 2 diameters. Circle 1, our inside diameter, datum A, and circle 2, our outside diameter, that we measured back to datum A. Because we've already measured these 2 diameters, there is no need to remeasure them. We can simply recall the measured features or measured diameters and apply our circular ring-out. To do this, we're going to select our circle 2 from our feature list on the left-hand side of our digital readout. After we've done this, we select tolerance, and then we select circular ring-out. We then key in a tolerance zone of 1.5 millimeters and ensure that our reference feature is set to the default, the feature previous, circle 1. Then we push finish. We have a circular ring-out of 1.312. This is within specification. This is how you measure circular ring-out in the readout.